So welcome to another video. In this video, we'll be looking at binomial distribution. Now, a binomial distribution is the simplest form of probability distribution. So the binomial distribution is basically a probability distribution. So it is basically a probability, so a form of probability distribution. So we have different probability distributions, but it is the simplest form of probability distribution. Now, for your binomial distribution is basically, write it down here, your binomial distribution is the distribution of a binomial, experiment. So that means the distribution of a binomial experiment is basically your binomial distribution. Now, it is the simplest form of distribution as I stated earlier, and it is used for discrete random particles. So it is used for discrete random particles. So it is used for discrete random particles. Now, your binomial distribution from the word bi, which is two, is basically binomial distribution basically means, or binomial basically means two categories. Let's put it this way. Basically means two categories. What do we mean by two categories? It's like I stated for discrete random particles, so it's a distribution for discrete random particles. So basically means two categories. Two categories in the sense that when we start speaking about the formula, you would understand what I mean by the two categories. So, for example, if you have an infected plant, the opposite or the second category will be what? A non-infected plant. If you have an infected patient, the opposite will be a non-infected patient. So two categories of a particular thing. Now let's look at the properties. The properties of binomial distribution. So the properties of binomial distribution. The first property is that the binomial distribution has a fixed number of trials. The binomial distribution has a fixed number of trials. The second one is that the activity, or we have two probabilities or two activities, which is your activity, your probability of failure, or two probabilities, which are probability of failure and probability of success. So probability of failure and success. So those are your two activities. The second one is, the third one, the probability or P. Let's put it this way. P is denoted as probability of success. P is denoted as your probability of success, which is constant also throughout. Now, these are basically a few of all the properties we have. Now, moving on to the calculation aspect of it. Now, your probability or your binomial distribution is given as P of x, which is equal to x, equal to n combination x, probability of x, which is P of x, q of n minus x. So this x is the one here. So see, or it could also be written as, or probability of x equals x is equal to n combination x. So you could write it this way: P of x, q of 1 minus P of n minus x. Now you get to understand this when we start solving questions. So let's look at a few questions and solve them on our own.
Continue.
So now we have our first question, which is suppose we have 5 coconut seedlings. Calculate A, the probability of having 0, 1, 2, 3, 4, 5 good seedlings. Now, going to our formula, which is this. We could either use this or we could use this. Now, P, as we stated before, let me write them down. P is our probability of success. Our probability of success. Let me use a black pen. Success. Q is our probability of failure. Now, N, which is basically your number of success, or you could say your number of samples. So, number of sample. Let's use number of samples now in this case. Number of samples. Now, our X is basically your probabilities or your number of successes. So the number of success, that's what we're looking for. So this X is basically your probability you are looking for. So probability you are looking for is your X. That's basically it. Now, moving to our formula before then, what is our N in this question? Our N in this question is equal to 5. Our N is 5. That is why we say we have a fixed number of trials. So this is basically a number of samples, or you could say a number of trials. Whatever it is. So we have a fixed number of trials. Now, our P in this case would be our probability of success. Now we say we are dealing with a binomial distribution. Now, we are not going to use these numbers we have here, or the 5 we have here. So the probability of success, let's say we have 2 coconut seedlings. One might be infected, one might not be infected. So the probability of having a good coconut seedling will basically be 1/2, and the probability of failure. Now, 1/2 is the same thing as 0.5. So 1 minus 0.5 will also be 0.5, which is also 1/2. So that's basically your 1 minus P. So anytime you are given P and you are not given Q, just basically 1 minus your P would give you your Q. And that's why we used 1 minus P here. So moving to this case here, we can now impute them in our formula. So basically, we are going to look for the probability of having 0 good coconut seedlings, 1 good coconut seedling, 2, and that's to get to 5. So starting with P of X equals to 0. So going to our formula, we have, which is N. Our N is what? 5. Combination, bring it up a little bit. Combination what? What is our X? Our X will be what? 0. So 5 combination 0. P of X, what's our P? 1/2 raised to the power of what? X, which is what? 0. And Q, which is 1/2 raised to the power of what? 5 minus 0. So you have this 5 combination 1. Now, if you don't have a calculator, your combination is basically n factorial all over n minus x factorial x factorial. So we can calculate this. Our n is what? 5. So we have 5 factorial divided by what's our n? 5 minus x, which was 0. So 5 factorial again, all over what? 0 factorial. Now we could basically, factorial is basically, if I tell you 2 factorial, it is 2 times 1. 3 factorial is 3 times 2 times 1. So it's basically just from the number you start going downward. So this 5 factorial will cancel out this 5 factorial. This is 1. Now, 0 factorial is not going to be 0. 0 factorial is actually 1. So there's an explanation to it. So 1 divided by 1 will be what? 1. So 5 combination 0. If you don't want to use this manual, you could go with your calculator. On your calculator, just basically write your number, which is 5. Shift, go to your shift key. Now, on the division sign, if you are using a Casio, if you are not using a Casio, look through your calculator, you see where there's NCR. Whenever you see this, click on it. That's your combination, 0, and you see you have 1. So 1. Anything raised to the power of 0 is 1. So basically, 1/2 raised to the power of 0 is what? 1. Multiply by, so this will be 1/2. 5 minus 0 is 5. So 1/2 raised to the power of 5 is basically 1 raised to the power of 5, which is 1, all over 2 raised to the power of 5, because this 5 will basically affect this and affect this. So 2 raised to the power of 5 is what? 32. So you could write it this way. 1 times 1 is 1. 1 times 1 here is 1. So it will basically be your P of x equals 0 will be what? 1 over 32. Or if you want to express it in another form, 1 divided by 32 would be what? 0.03125. So this would be your answer for P of x equals 0. Moving to P of x equal to 1. So we'll apply the same thing now. You know we have a fixed number of trials. So 5 combination 1, P of x, which is what? 1 over 2 raised to the power of 1, multiplied by 1 over 2 raised to the power of what? 5 minus 1. So we'd have 5, 1, 1 over 2 raised to the power of 1, 1 over 2 raised to the power of what? 4. Now to get 5 combination 1 with your manual method, it will basically be 5 factorial all over 5 minus 1 factorial, because it's n minus x factorial, so 1 factorial. Now this would basically be 5 factorial divided by 5 minus 1 is what? 4, so 4 factorial, 1 factorial. Now we can write 5 factorial as 5 times 4 factorial, because it's supposed to be 5 times 4 times 3 times 2 times 1. So 5 times 4 factorial. So 4 factorial is 4 times 3 times 2 times 1. So divided by what? 4 factorial, 1 factorial. This 4 factorial will cancel out this 4 factorial. 1 factorial is basically 1 times 1, which is 1. So 5 divided by 1 is 5. So if you go to your calculator, the same thing. 5 shifts combination 1 will basically be your 5. So you'd have 5 multiplied by, this is 1 over 2 raised to the power of 1, which is 1 over 2, multiplied by 1 raised to the power of 4 is 1. 2 raised to the power of 4 is what? 16. So 5 times 1 is 5. So we'd have 5 divided by 2 times 16 is what? 32. So P of x equals 1 is basically 5 over 32. Or you could say 5 divided by 32 would be what? 0.15625. So you could perform it in this way. Next one will be P of x equals to 2. So P of x equal to basically be 5 mention 2, 1 over 2 raised to the power of 2, and 1 all over 2 raised to the power of 5 minus 2, which is what? 3. So we all understand it now. So I can go with my calculator. 10 multiply 1 over 4 multiply 1 over 8. So this would basically be 10 times 1 times 1, which is 10, divided by 8 times 4, which is what? 32. 10 divided by 32 would basically be what? 0.3125. So this is the answer to this. Going to the next one, P of x equal to 3. We have 5 combination 3, 1 over 2 raised to the power of 3. We have 1 over 2 raised to the power of what? 5 minus 3, which is what? 2. So your 5 combination 3 would be 10 also. 5 combination 3 will be 10. Multiply by 1 raised to the power of 3 is 1. 2 raised to the power of 3 is 8. 1 raised to the power of 2 is 1. 2 raised to the power of 2 is what? 4. So basically, we're going to have the same answer as this guy here. So we'd have 10 over 32, which is what? 10 divided by 32, which is 0.3125. Now, going to P of x equal to 4. We have 5 combination 4, 1 all over 2 raised to the power of 4, and 1 over 2 raised to the power of what? 5 minus 4, which is what? 1. So we'd have 5 combination 4, which is 5, multiplied by 1 raised to the power of 4 is 1, 2 raised to the power of 4 is 16, 1 raised to the power, so this will be 1 raised to the power of 1, which is 1, 2 raised to the power of 1, which is what? 2. So this will be basically be 5 times 1 times 1, which is 5, 5 over what now? 32. Now 5 over 32 would be what now? 0.15625. We've done it here. So you start seeing a transition in how we are moving. So with this, we'll end here. You will look for P of X equals 5 and drop your answer in the comment section. I would love to hear from you. So let's look at another question. So we have another question. Now in this question, we have that in a batch genetically modified crops, each plant has a 70% chance of being resistant to a common disease. A sample of 10 plants were used. What is the probability that at least 4 are disease resistant? What is the probability that at least 4 are what? Disease resistant. So let's use a U pen. Now, first of all, to start, you have to list out your parameters. Don't forget our formula, P of X equals X is equal to N combination X, P of X, Q of X, or you could say 1 minus P, sorry, not Q of X, N minus X, or you could say 1 minus P, N minus X. So regardless of which we use as Q. Now, for this case, what is our P? Our P is 70%. So they say what has a 70% chance. Don't forget, probability is what is a measure of chance. So P, which is this P here, not this P here, this P here. So this P would be equal to 70%. So 70%, which is the same thing as saying 70 over 100. Now, 70 over 100 would basically be 0.77, or you could say 0.7, say the same thing. Now, since our P is equal to 0.7, now our Q would basically be 1 minus 0.7, which is what? 0.3. Now, since we have our Q, what is our N? Our N is our number of trials. So how many samples did we use here? You say a sample of 10 plants were used. So N is equal to 10. Now we are looking for the probability. The probability, now the X basically here is saying that, let's say X, which is our probability or the number of successes we have. So the probability we are looking for is, we are looking for the probability that at least 4 are resistant. At least. So that means at least meaning the minimum. The minimum is what? 4. That means the minimum that 4 crops are disease resistant. So that means 5 could be disease resistant, 6 could be disease. Imagine a scenario where I say at least 10 people are invited to my party. That means 20 people can come, 30 people can come. That means the minimum is what? 10. So in this case, the minimum is what? 4. So what we're basically looking at is X greater than or equal to what? 4. So in this case, we are meant to find the probability of X equals 4, X equals 5, X equals 6, X equals 7, X equals 8, X equals 9, X equals 10. It is a very tedious process. So we are going to shorten how lengthy our work is supposed to be by using a principle of probability. Now, probability always ranges from 0 to 1. That means probability cannot be greater than 1 and it cannot be lesser than 0. So, if probability cannot be greater than 1, what it therefore means is this, is you can now say that P of X P of X greater than or equal to 4, which is what we are looking for, plus what is the opposite of this? The opposite will be P of X less than 4 equals 1. That means the probability that at least 4 will be resistant, or the probability that you could also change this to be less than or equal to 3. You could put it that way, but it's still the same thing, I guess, because 4 is not inclusive, because 4 is inclusive here. So the probability that X is less than or equal to 4 plus the probability of X greater than or equal to 4 plus the probability of X less than 4 equals 1. That is the rule. So the rule is we are dealing with binomial distribution. So this plus this should equal the probability of these guys and the probability of these guys should all equal 1. So we can now find that P of x greater than or equal to 4 will be equal to 1 minus the probability of x less than 4. So we can look for this. To look for this, we just have to find 0, 1, 2, 3. That's 4. So we are shortening the length of the bulky work we're meant to do here. So finding for this probability here, we can now start with P of x equals 0. So P of x equals 0 will basically be, what is our n? Our n is 10. So it will be 10 combination 0. P is what? 0.70. So 0.70 raised to the power of what now? 0. Then we now have 0.30 raised to the power of 10 minus 0. So if you do this in your calculator, always bear this in mind. 10 combination, any number combination 0 is 1. That's it. So this 1 times, we can now have 0.70 raised to the power of 0 will be 1 multiplied by 0.30 raised to the power of 10 minus 0 is 10. So raised to the power of 10 would basically be 0.000059. So if you multiply all of these, you would have that P of x equals 0. The probability of x equals 0 is 0.000059. So we found this. We can now go to the next one. The next one we have that P of x, equals 1. So P of x equals 1 would basically be 10 combination 1. Now 0.70 raised to the power of what? 1, because P of x, P raised to the power of x. Then we now have 0.30 raised to the power of 10 minus 1. So 10 combination 1, any number combination 1 will give you the number here, so 10 multiplied by 0.70 multiplied by now 0.30 raised to the power of 10 minus 1 is 9. Raised to the power of 9 will basically be 0.000019683. So if you multiply this, all of them together, should basically be having 0.000137781. You could write it this way. You could approximate if you want, but to reduce the likelihood of error, it's best you write them in this way. So we'll look for P of x equal to 2, which will be 10 combination 2, 0.70 raised to the power of 2, 0.30 raised to the power of 10 minus 2. So having this, 10 combination 2 would basically be 45. So 45 times 0.7 raised to the power of 2 would be 0.49 multiplied by 0.30 raised to the power of what? 10 minus 2, which is what? 8. Raised to the power of 8 will be 0.00006561. So multiplying all of these together would have 0.001447. So we could end here. Now we can look for P of x equals to 3, which will be 10 combination 3, 0.70 raised to the power of 3, 0.30 raised to the power of 10 minus 3. Now 10 combination 3 should give us 120 multiplied by 0.70 raised to the power of 3 would be 0.343 multiplied by 0.30 raised to the power of 10 minus 3 is 7, so raised to the power of 7, 0.00022187. Multiplying all of this together would have 0.00900. So we could end here. Now, if we have this, at first we're looking for P of x equal to 4. So which will be definitely 1 minus P of x which is what we are looking for, less than 4. So which is same thing as 1 minus p of x equals 0 plus p of x equals 1 plus p of x equals 2 plus p of x equals 3. So this is basically what we did. We have found p of x equals 0, p of x equals 1, p of x equals 2, p of x equals 3. Now, what we basically do is p of x, which is greater than or equal to 4, is equal to 1 minus. Now, p of x equals 0 was 0.00. We have 5 zeros here. Yes, we have 5 zeros here, 59, plus p of x equals 1 plus p of x equal 2, and we have plus p of x equal 3, 0.009. So we can end there. Now summing them up, we have 1 minus summing them up, we have 0.01059037881. And if you minus 1, 1 minus this value would have 0.989. So you could end here. So the probability of x greater than or equal to 4 is 0.989. And this is the end of our question. Now, initially, if you checked the original question we started solving, we're asked to calculate the mean and variance of the experiment. I intentionally omitted it because I wanted us to solve this before getting back to this. Now, the mean, which is given as mu here, or it is also given as your expected value. So you could either be called mu or it be called your expected value, is n times p. But your variance, so population variance, is given as n times p times q. So for this question we are solving, we solved here initially. Our n was what? Our n was 5. We looked at it, n is 5. Our p was 1 over 2. So basically, the mean of this question would be 5 times 1 over 2, which is what? 5 over 2. Our variance would be n times p times q, which is 5 times 1 over 2 times 1 over 2, which is basically 5 over 4. You could also be asked to find the standard deviation. Basically, your standard deviation is given as this. It is the square root of your variance. So your standard deviation, this is your standard deviation. Standard deviation. So it's the square root of your variance. Now, our variance we got was 5 over 4, which can also be expressed as 1.25, 5 over 2, which can also be expressed as 2.5. So the variance we have is this. So this is our variance. Let me write this here. And this is our mean. So this is formula for your mean, this formula for your variance. Our variance was what? 1.25. So basically your standard deviation will basically be the square root of 1.25, which would be 1.12. So this is approximately 1.12. So this is your standard deviation. This is the standard deviation. Now, based on this knowledge, calculate the mean, variance, and standard deviation of this particular question. Drop your answer in the comment section. I would love to hear from you guys. So you have two things to do for me, which is finding the probability of x equal 5 and the mean, variance, and standard deviation of this particular question. Thank you very much. Thank you. Hit the like button, hit the subscribe button, hit the subscribe button, hit the share button, share to your friends, to your colleagues, and the rest. I'll see you in the next video.